Migration of ions. Today I'm going to talk about the migration of ions, which is the movement of charged particles. Electric field is applied. I'll be describing two experiments which show this clearly: the coloured ions, and explain which ions move, the colours, the apparatus used, and the safety hazards involved. So, what are migration of ions? The migration of ions happen when the ions move in response to electric field. Positively charged ions called cations move towards the negative electrode, which is the cathode. Negatively charged ions called anions move towards the positive electrode, called the anode. This movement proves that the ions and the charged particles, and also explains how ionic substances conduct electricity when the ions, in that case, are free to move. Here is the experiment with potassium manganate. In this experiment, potassium manganate is placed in an agar gel on damp filter paper between the two electrodes. A power supply is connected to create an electric field. The agar gel helps to keep the solution still so the movement of ions can be clearly seen. Ions and observations. Here are the apparatus you would need. And what occurs is that the potassium manganate, since it contains the potassium ions, which are colourless, and the manganate ions, which are purple. When the voltage is applied, the purple manganate ions move towards the positive electrode, which in this case is the anode, and the potassium ions move towards the cathode, but they cannot be seen because they are colourless. This therefore shows that the negative ions migrate towards the positive electrode. Hazards. Potassium manganate is an oxidizing agent and can stain the skin and clothes. Safety goggles and gloves will be worn to prevent contact with the eyes and skin, and any spills will be cleaned up immediately. Experiment 2. Copper chromate U-tube. In this experiment, a U-tube is filled with copper chromate solution. Electrodes are placed at each end of the tube and connected to a power supply. The U-tube allows the ions to move in opposite directions, making the separation very clear. Ions and observations. So, the copper chromate contains the copper ions, which are blue, and the chromate ions, which are yellow. When an electric field is applied, the blue copper ions move towards the cathode. The yellow chromate ions move towards the anode, resulting in a clear separation of the colour in the two arms of the U-tube, providing strong evidence cations and anions migrate in opposite directions. Hazards. Copper chromate is toxic, and chromate ions are carcinogenic. Gloves and goggles must be worn at all times. Skin contact must be avoided, and the chemicals will be disposed of properly, according to lab safety rules. Here are some other experiments showing ion movement. Those other experiments also demonstrate the migration of ions. For example, during the electrolysis of molten lead bromide, lead ions move, cathode lead metal forms, and bromide ions move, the anode, where bromine gas is produced. These experiments further support the idea that ions move electric field. In conclusion, the migration of ions shows that ions are charged and move in specific directions. Electric field is applied. Coloured ions such as manganate, copper, and chromate ions make it visible. Cations move towards the cathode, and anions towards the anode. This explains how ionic substances conducting electricity when ions are free to move.